Hey, what's going on, MathCounts? Here we go. We got warm up number 6 from the 2026 problem set. Problem number 81. A list of 4 positive integers has a median of 5. What is the least possible mean of the list? All right, so we got 4 numbers. 1, 2, 3, 4. And we know that the median, the halfway between them, is 5. So the average of the second and third number is 5. And we want the least possible mean of the list. So we want the smallest numbers possible. So if 5 is the median right here, we could do 4 and 6. But that would mean that this number here, the smallest it could be, would be 6. So the best 2 numbers to use here are 5 and 5, because that would give us a median of 5, which allows us to use 5 over here. And then down here, we would use the smallest number possible, which would be 1, because we're looking at positive integers. So it would be 1, 5, 5, 5. That's 16. The mean is the average, so 16 out of 4 is 4. So 4 would be the least possible mean on the list. Next one. If x plus x squared equals 6, what is the least possible integer for x? Okay, so when they're talking about an integer, remember that does include negative numbers. You might be tempted to just kind of think of numbers and go, oh, 2, because 2 plus 2 squared is 6. But what we can do to find the actual 2 numbers is the process called factoring. So I'm going to move everything to this side of the equation. So I've got x squared and x. And I'm going to subtract 6 from both sides. Okay, so here we've got a quadratic. We've got an x squared. So anytime that your largest term has a squared, that means that you can have 2 solutions there. It's possible. 2 is the maximum number of solutions. So what are the 2 solutions? Well, we're going to factor, and let me just show you the quick way of factoring. I can post I don't even know if I think I do have a lesson on how to factor. So if you look up the lesson on how to factor, you can do that. Whatever. So what you're going to do is you're going to look for what number multiplies to give you negative 6, but adds to give you positive 1. So what 2 numbers multiply to give you negative 6, but add to give you positive 1? And that would be 2 and negative 2 and positive 3. So I can now factor using this 2, this negative 2, and this 3. Factoring is just undoing the distributive property. So I'm going to turn it into a multiplication problem. So the x squared is just x and x, and then we use these 2 numbers, minus 2 plus 3. All right, so I've got x minus 2 times x plus 3 equals 0. Now the only way for us to multiply 2 numbers and get 0 is if one of those numbers is 0. So we have, two possibilities here. X minus 2 could be 0, and x plus 3 could be 0. So I can say that x could be 2, which is what we talked about earlier. 2 plus 4 equals 6. But the other possibility is x could also be, subtract 3 from both sides, negative 3. So remember we said it's a quadratic. We have an x squared. There's going to be a maximum of 2 possible solutions. So we've got 2 and negative 3 are the possible solutions for this one. The least integer value would be negative 3. So negative 3 is our answer. So your largest exponent in your polynomial tells you the maximum number of possible solutions. So if this would have been x to the third, there would have been a maximum possible of 3 solutions to it. Since we had an x to the second, there are 2 solutions, and we can solve those by factoring. Number 83. A bathtub has a faucet that fills it completely in 10 minutes and a drain that empties it completely in 15 minutes. The bathtub is currently half full. If the drain is open while the faucet is on, how long will it take to fill the tub completely? Okay, so I do these as work problems. It's probably not how the book would do it or whatever, but here's how I do it. Okay, so we have two things working against each other. We've got it filling up and we've got it draining, two different rates. So what I'm going to do is I'm going to look at what is it doing in 1 unit of time. So if it can fill it up in 10 minutes, that means in 1 minute it can do 1/10 of the job of filling up the tub. That's filling it up completely. If it's draining in 15 minutes, in 1 minute it can drain 1/15 of the tub. So fill up minus draining, and then that means in 1x of the job, it will fill up the tub completely. So in 1 minute of time, how much of the job will it do? And now we can just multiply by the, what's it called, LCM? I don't know, whatever. I can't remember. What number goes into 10, 15, and x? Well, the smallest number that goes into all those would be 30x. So 10 goes into 30, I'm left with 3x. 15 goes into 30, I'm left with 2x. X goes into 30x, I'm left with 30. I subtract these two to get together and I get x equals 30. But this is the full tub. It takes 30 minutes to fill up the whole tub, but we only want half the tub. So half of 30 would be 15. 15 is our answer. You probably have a different way to do it. If you've got a different way that you like to do it that looks easier than the way I do it, go ahead and put it in the comments. Help other people out. Next. Anu randomly cuts a ribbon of length 14 inches into 2 pieces. What is the probability that the difference in length between the 2 pieces is 3 inches or less? Express your answer as a common fraction. All right, so let's just get a visual representation. We've got this ribbon. It's 14 inches long. We're going to cut it somewhere. We want to know the probability that when we cut it, it's going to be 3 inches or less of a difference between the 2 pieces. So we're going to cut it somewhere. All right, so if I cut it right down the middle, that's 7 inches and 7 inches. So that would be 3 inches or less. So I know I can cut it somewhere around here. In order to find out exactly where I can cut it, I can look at the difference between A and A minus 3. A is where I cut it, or the length of this segment here. A minus 3 would be the length of the rest of it. So I'm going to do A plus A minus 3. So the bigger segment and the smaller segment, those two together, so the difference between, or when we add them up, we get 14. So the bigger segment and then the smaller segment, which is 3 less. So I get 2a minus 3 equals 14. Add 3 to both sides, I get 2a equals 17. Divide by 2, I get a equals 8.5. Okay, what's that telling me? It tells me that I can have the first one be over here, a cut at 8.5. The second cut would be the smaller segment that I could do. The second cut would be 8.5 minus 3, which is 5.5. Any cut in between here, so if I cut the smaller and make it 5.5, the rest is 8.5. So that would be a difference of 3. Over here, if I made the big cut 8.5, I would have 5.5 over here, and then that would make a difference of 3. So basically, any cut in between here would work. because this is the maximum cut I can make. A cut down here at 5.5 and a cut down here at 8.5. So what's the range here between these two? The range from 5.5 to 8.5, I've got this section, a 3-inch section, that I could cut it. So 3 inches out of a total of 14 inches is the section that I could cut in. So that would be 3 out of 14. Next one. Matt and his friend Maddox, oh God, order a pizza that's 2/3 vegetarian and 1/3 pepperoni. Matt eats 1/4 of the vegetarian pizza and 2/3 of the pepperoni. Maddox eats 2/3 of the vegetarian and 1/4 of the pepperoni. How much of the pizza is left? All right, let's just see how much they actually eat. Gosh, hiccuping. So let's start with Matt. Matt eats 1/4 of the vegetarian, which is 2/3. 2/3. You can't see that. There we go. Sorry. Did I do that on the last problem? I wasn't even paying attention. There's the last problem if you didn't see it. Sorry. Anyways, all right, so there's Matt. He eats 1/4 of 2/3, and he also eats 2/3 of 1/3. He eats 2/3 of the pepperoni. So right here, we've got that he is eating 2/12, which is 1/6. And he's also eating 2/9 of the pizza. All right, then you've got Maddox. Get it, mathematics. Maddox eats 2/3 of the vegetarian, so he eats 2/3 of the pizza that's 2/3. And then he also eats 1/4 of the pepperoni, 1/4 of 1/3. So he eats 4/9 of the pizza, and he eats 1/12 of the pizza. So let's see how much they ate together. Let's see, what number does 6, 9, 9, and 12 all go into? That would be 36. So we got 36. This is 6/36. This is 8/36 because I multiplied the top and bottom by 4. This is 16/36. And this is 3/36. So together, how many 36 have they eaten? 14, 33. So we got 33 out of 36 has been eaten. So what has not been eaten is 3 out of 36, which is 1/12 of the pizza. All right, 86. A cyclist has completed 2/3 of his route when he gets a flat tire. He walks the rest of the way and spends twice as much time walking as he did riding. How many times as fast does he ride his bicycle as when he walks? Okay, so he does 2/3 of the route, which means he has 1/3 left. So he only has to go half the distance when he walks. But when he goes half the distance, he spends twice the time. So if you go the full distance, if you multiply both sides by 2, the full distance would take 4 times the time. So the other dude must be going 4 times as fast. I mean, on the bicycle, it must be 4 times as fast. Is that the right answer? Yeah, it's the right answer. Good. Next, let f of x equal the square root of x plus 1 and g of x equal x squared plus 1. What is g of f of 8? All right, so g of f of 8 simply means this. We plug 8 into f of x, get an answer, and whatever answer we get, we plug it into g of x. So let's start by finding f of 8. f of 8 would equal the square root of 8 plus 1, which is the square root of 9, which is 3. So f of 8, not square root of 3, dang it, f of 8 equals 3. Okay, so if f of 8 equals 3, now all we have to do is find g of 3. So to find g of 3, we would just plug in 3 into the x. G of 3 would equal 3 squared plus 1. So that's 9 plus 1. G of 3 must be 10. Next, Lola and Sosa are making cones out of clay in their art class. Sosa's cone has a radius that is 3 times that of Lola's and a height that is half of Lola's. What's the ratio of the volume of Sosa's cone to the volume of Lola's cone? All right, we want to compare Sosa to Lola. That's what we want for our ratio. So, Sosa, since it's a cone, it's going to be 1/3 the radius squared times the height. 1/3 the radius, which is 3r, times the height, which is h over 2. Or we can call this just 1/2 of h. That's probably better. Let's call it 1/2 h. Lola is just 1/3 the radius squared times the height. All right, let's work this out a little bit. Well, first of all, I can just get rid of the 1/3. That'll make it a little bit easier. And then here, 3r squared is 3r times 3r, so that's 9r squared times 1/2 the height. Over here, I've got r squared times the height. So the r's cancel, the h cancels. What am I left with? Well, in the denominator, I'm left with 1. In the numerator, I'm left with 9 times 1/2, or 9/2. Write it as a common fraction. It's 9/2 to 1 as our ratio, so 9/2 is our answer. Is that the answer? That was the answer. Good. Almost there. If 6 clanks are in one clink, okay, so I'm going to call this 6 A's for clanks, and 1 clink, I'm going to call those I's. And there are 12 clinks, those are I's, and 9 clonks, I'm going to call those O's. So these are clinks, clonks, clanks, clinks. How many clanks are in one clonk? Okay, so I want clanks as my answer, right? Do. So I'm going to do this. I'm going to multiply by 1 clonk. Why did I do that? Because the clonks are going to reduce, the clinks are going to reduce, and now my units are just in clanks. So I've got 1 clonk. If I multiply these two ratios by 1 clonk, the clonks reduce, the clinks reduce, my only unit left is clanks. So I can do, let's reduce this first. 3 goes into both of these, so this is 3 and this is 4. So I get 24 in the numerator, 3 in the denominator. Looks like I get 8 clanks. Is that the answer? It is the answer. Last one. 2 fair 6-sided dice are rolled. What is the probability the number showing on one of them is twice the number showing on the other one? Okay, so if I'm rolling 2 dice, there's 6 ways to get the first one. There's 6 ways to get the second dice. That is a total of 36 different ways to get an outcome from 2 dice rolls. So that's my denominator. Now I want to know what is the probability that the number showing on one of them is twice the number showing on the other one. Okay, so if the first dice roll is 1, the second dice roll could be 2. So there's where it could be doubled. If the first dice roll is 2, then we could also say that the other one would be 4. So that's a double. If the first dice roll is 3, there we go. So that's where the second dice roll is the double of the first one. We can also go backwards and say, okay, what if the first dice roll was 2? Then we can go half going this way. So half of 2 is 1. Then we can say, okay, what if the first dice roll was 4? The second dice roll could be 2 because it could be half. And what if the first dice roll was 6? Then the second dice roll could be 3. So it looks like we have 6 outcomes where the one is half of the other one. So this one, it's where the second is twice. This one, it's where the first one is twice. So there's 6 outcomes out of a total of 36 outcomes, which is 1/6. The end. All right, keep mathing hard. I will see you later. Bye-bye.